Moxonix, yes? We'll have early lunch for one. Yeah. Okay, we're on 35. And 35 says use identities to find exact values of the indicated trig functions of the acute angle theta. So on 35, we have that the cosine of theta is equal to the square root of 10 over 10. And we want secant theta, which is the reciprocal of it. Yes. All you do is rationalize a denominator. It's 1 over cosine of theta, which means I have 10 over the square root of 10. And I get the square root of 10. All right. And now we're going to do, cotangent. Okay. This is funny, right? We know if the cosine is a square root of 3 over 2, it is pi 6, right? Yeah. And what do we know about the other one? It's a half in the ordered pair. And they want, cotangent. Okay. Yeah, so, okay, we got to figure that one out. But we know that this is in our unit circle. And this is equal to pi 6, right? And so we know the ordered pair would be the square root of 3 over 2 and a half. Yes? Okay. Just, if I'm doing some, we could work it all the way they want, which is, we know that the cosine of theta equals x over r, right? We can do it that way too, and just use the Pythagorean theorem to get the other part, but I'm pretty sure it's a half. Okay, so now cotangent then is y over x, if we're looking at the ordered pair. So this is going to give me the 1/2 divided by the square root of, the other way, sorry, x over y. It's a reciprocal of tan. Sorry, my brain was on tan. So it's going to be the square root of 3 over 2 divided by the 1/2, which gives me, square root of 3 of the cotangent. Okay, now on this one, it's talking about on 37, we're using a point on a circle, and that is x squared plus y squared equals r squared. And we understand that gives us a specific point for that perpendicular. Okay, anyway, we've got, it's a circle, and it says find the cosine of theta, find the indicated cosine of theta. So this means that I have the ordered pair 5 and 12, which is x and y. Is everybody comfortable with that? Okay, so because this is the length of that hypotenuse that we're looking for. And that gives us 5 squared plus 12 squared equals r squared. 25 plus the 144, right? Equals r squared. 169 equals r squared. Oh yeah, it is what? 13 equals r. So we know, because they're positive, they are in that first quadrant, and they want find cosine of theta, and we know cosine of theta is x over r. Therefore, cosine of theta is 5 over 13. You knew that. Yeah, it's been a while, but yeah, you know that. Okay, this one is 4 and 3. And again, I'm not giving you negative numbers. I'm not doing any of that. I just want you to know what you know. So this time we're going to have the 4 squared plus the 3 squared equals some r squared. 16 and 9 equals r squared. 25 equals r squared. So we've got a radius of 5. And they want us to find sine. 3/5. Yes. Okay. We want exact values here. And this is asking for angle. Any inverse trig function is looking for angle. All right. Now again, this is a unit circle. The sine, inverse sine, and this is 39. Inverse sine of the square root of 2 over 2 is 45. All right. We understand that that is, and we have that in 2 positions, right? 45 here is going to be the square root of 2 over 2 over the square root of 2 over 2. And it is positive in this one here. And it didn't give us a parameter, and I always get upset when they do that. This is negative square root of 2 over 2 and positive square root of 2 over 2, which that guy is, what, 130? So, did it want both angles or just quadrant 1 angle? Pi fourths. It wanted radian on top of it. Okay. If you gave me 45, because it wasn't really specific, that's fine. So they only wanted quadrant 1. But it didn't say quadrant 1, did it? No. Yeah, yeah. This makes me crazy. So we're looking at... Okay. This one wants a square root of 3 over 2, and this is pi 6. Because it's cosine, so it's the x value. And this one wants tan inverse of 1. Well, the only way that's going to happen is in 2 of them, the 45 here and the 45 here. But I'm sure they're wanting just pi fourths. I'm guessing. Is that what they want? Because the other ones were first. Yeah. Only quadrant 1. I'll make sure I tell you. I might want both of them. You know what I mean? Yeah. Okay. Now we want, let's look 42. Tan inverse of the square root of 3 over 3. Tan is what? Y over x, right? Y over x. Well, where is y in the square root of 3 over 2? At pi thirds. It is 1/2 and the square root of 3 over 2. So it's this guy divided by that guy. It's the square root of 3. Oh, but it wants it over 3. Ooh, it's not. It is pi 6. Pi 6. The opposite. So it's pi 6. Because I need the square root of 3 over 3. I need this guy on the bottom. Sorry about that. It took me a minute. All right. Now this guy right here is cosine, sine inverse of 1/4. All right. Okay, we can do this under cosine squared theta plus sine squared theta equals 1. We can do that. Or we can use the Pythagorean theorem, one or the other. Which one you want? All right, okay. Because we're looking for cosine. So cosine squared of theta plus 1/4 squared is equal to 1. So if I subtract the 1/16, it's going to be 15/16, isn't it? I'm going to take the square root, and that's going to give me cosine of theta equal to the square root of 15 over 4. Is that good? Okay, I'm going to stop there, and we'll start there, and we'll maybe have a short class. Okay, because we're getting into the law of sines and cosines and that part. Is everybody comfortable with that? Any questions, gentlemen? We are, if you want, I will hang up